We're discussing examples to try to understand continuity. In this example, from problem 36, the function is continuous. The function is that the f of z is the absolute value of z. So the graph looks something like this, as we all know. And then the question is, how far is the value of the function at x from the value of the function at a base point A compared to the distance between x and A? Well, if x and A are on the same side of 0, then the distance between the absolute values is just the distance between those 2 points. And if they're on opposite sides, then the distance between the absolute values is actually less than the distance between those 2 points x and A. So one way or the other, the absolute value of x minus the absolute value of A is less than or equal to x minus A. Now, when we're considering continuity, we're trying to show that the difference between the values of the functions can be made small by choosing the distance between the points at which the function is evaluated small. So in terms of our notation, we have an epsilon bigger than 0, and we want to show that the distance between the values of the function is less than epsilon. And we wanted to show that that's true when the distance between the 2 points at which the function is evaluated is delta. In this case, it's pretty obvious that the distance between the values of the function is less than the distance between the points. And so given epsilon bigger than 0, we set delta equal to epsilon, and then x minus A less than delta implies that the distance between the absolute value of x and the absolute value of A is less than or equal to the distance between x and A, and that is less than delta. And by our choice, that makes the distance between the absolute values less than epsilon. To make sure that we understand how the definition of continuity helps decide whether a function is continuous or not, let's look at an example of a function that is not continuous at a certain point. So for t equal to 0, we're setting g of 0 equal to 0. If t is not 0, we're letting g of t equal to sine 1 over t. If t is not 0, 1 over t is a well-defined number, and of course sine of it will be something between minus 1 and 1. So what are we trying to show? We're trying to show that you cannot make the difference between sine 1 over t and 0 small by making sure that t is close to 0. And here's why. If we take tk to be 2 over the whole quantity 4k plus 1 pi, and you'll see this is a multiple of 2 pi and then one more copy of pi, then 1 over t to t sub k, that's going to be stuck in here, is equal to 1 over this, which is 4k plus 1 pi over 2, and that is pi over 2 plus 4k over 2 pi, which is 2k pi. Now if we evaluate sine at this point, sine at pi over 2 is 1, and any multiple of 2 pi doesn't change the value of sine. So sine at 1 over tk is equal to 1 no matter what k we choose. So for any integer k that we choose, sine of 1 over t sub k is going to be 1. Let's see how that plays in the definition. Let's think of the definition of continuity. the definition of continuity says that for every epsilon something happens. So the contradiction of that is that for some epsilon, that thing that's supposed to happen doesn't actually happen. And so we're going to show that the function g is not continuous by showing that a particular epsilon things don't work for. So we've chosen epsilon, or I've chosen epsilon equal to 0.4. You'll see soon that there are lots of choices. Now, what's supposed to happen? It's supposed to happen that there is a delta so that when t is within delta of 0, the difference between g of t and 0 is within 0.4. So that there does not exist a delta means that for any delta bigger than 0 that we might choose, what's supposed to happen doesn't happen. So we need to show that no matter what positive delta is chosen, the tolerance of 0.4 is not met. We already saw that these points t sub k are such that sine of 1 over t sub k is 1. And what we're saying is that if I take k sufficiently large, t sub k is going to be within delta of 0. Now it's obvious that t sub k is approaching 0, and so that is true no matter what delta it is. So there is a delta, fix any delta, just a particular one, but any positive one. Then there is some k for which tk is within delta of 0. And so g of tk minus g of 0, which you recall is 0, is equal to 1 minus 0, which is 1, and that's bigger than 0.4. And so, with epsilon equal to 0.4, that tolerance cannot be met, no matter what delta we choose. And so this function g is not continuous at 0.